Welcome back for more topic 14 stuff on digital storage. In this one, we're going to talk about those little pixels, what their quantum efficiency is, which is a word you can impress your friends with. And a less impressive word is the magnification of your camera. And then we'll discuss why on pixels they have to, what has to happen for an image to be just resolved on your CCD camera. Your camera will have lots of megapixels, and each of those millions of pixels, each one of them is a little capacitor. And you are going to have some photons that are going to come through your camera and hit that pixel, and then things are going to fly off of them. Those are going to be electrons. Ideally, for every electron or for every photon coming in, you'd have one photoelectron emitted, but it's not a perfect world, so you won't have that. And so to describe the quantum efficiency, let me drag this definition on, and you can take a minute and pause it and write that down. But the definition is pretty simple, and an easy equation comes out of it. And what that equation is that the quantum efficiency is going to be n sub e divided by n sub p, which you can guess on based on the definition that this n, photoelectrons emitted, and this n sub p is the number of incident photons. And in this situation with real film camera, you may only have maybe a 10% quantum efficiency, but what's nice about your CCD camera, it may have as high as 90%, which should make you feel good about what you purchased. Now for magnification, you're going to have your lens, and behind the lens you got your little CCD surface, which may probably be a few centimeters across. The light from an object, such as this nice giraffe that I've drawn, is going to come through here, and that's going to make clearly a much smaller image on your CCD camera, unless your camera is the size of a giraffe, which would be impressive. And you're going to make a ratio of these to get your magnification. And let me give you the definition of that. And take a minute and write that down. The very simple equation for that, we usually use a capital M for magnification, and I always like to remember it as high over ho, like the dwarfs used to sing, hi ho, hi ho. And this is your image height, which is your high, and the big ho is the object height. And so clearly in this case, or well, not always, but usually you're going to have an image, which is quite large, an object height, image would be quite small, and your object height, like your giraffe, would be quite large. And so in this case you would end up with a magnification that is well smaller than 1. You want to have the best resolution possible so that you can see all the interesting small features on your photographs on your CCD camera. And if you look again at what's happening, it says that 2 points can be just resolved if they're at least 2 pixels apart. So let's say that we're looking at the horns on our friend the giraffe in the last slide. And those horns on top of his head are going to be like this on the camera. And they're on pixels that are just next to each other. They're only 1 pixel apart. You can't resolve that because these will just look like one big blur because there's no space in between them. And what you can remember then is this fact in here that's red, that as long as there is an unused pixel between those 2 images, then you can just resolve them. So, for example, let's say that I've got my giraffe head again, and here's the horns on top of his head. As long as there's space in between where you will see that there's something, nothing, and then something, then that is just resolved.